Hello everyone, this is a beautiful question of the rotational mechanics, rigid body dynamics. So here we have a solid disk and there is an axis passing like this. This disk is free to rotate about this axis. Here is a light inextensible string. This is the light inextensible string, this one. It passes over the pulley and question says the string does not slide over the pulley. Means here is friction between the string and pulley and there is no slipping, there is no sliding. Now this mass M has to go down. So we consider the gravitational force on this mass as mg like this and acceleration of this mass we show down like this. If this mass is going down, this has to go up. The gravitational force on this mass we will show as m by 2g and its acceleration is directed up. This string will have the tension. So here the tension we are showing as T1 and here the tension we are showing as T2. We are making the free body diagram. Why the tension is different? The cause is the friction here. There is friction between the string and the pulley. Due to that friction, the tension here and the tension here will be different. Okay. Now the question is asking us the angular acceleration of the disk, means we have to find the alpha of the disk. Suppose we imagine the angular acceleration of this disk like as shown here. We call this as alpha and we have to obtain that alpha. To obtain the alpha, let us focus on the disk once. Here is the disk. Some part of the string we show along with the disk like this. At this point and at this point we show the forces. So here I should bring the force T1. Here I should bring the force T2. Okay. The disk has its own mg. There will be some hinge force also. Force due to hinge, although we don't require that force due to hinge in that calculation, and the angular acceleration of the disk is shown in this sense, the clockwise like this. Okay, about this axis the disk has the angular acceleration alpha. Done. Now about the center of the disk we are going to write the torque. Torque about the center of the disk is equal to moment of inertia about the center of the disk into alpha. Torque is equal to I alpha, you remember. While writing the torque, we consider this distance as r, which is perpendicular distance to the T2. So the torque will be RT2. This torque will be actually dominating torque because the system has the angular acceleration like this. So whatever torque is producing, that angular acceleration that is dominating. See the sense of angular acceleration. See the sense of this torque RT2. Both are directed into the plane of the board. Obviously this is dominating. Then we look at RT1. RT1 is the opposing torque. It is coming out of the plane. The RT2 was into the plane in the sense of the angular acceleration. Alpha's direction is also into the plane and RT2, that torque is also into the plane. RT1 is the opposing torque coming out of the plane. So I am putting a negative sign here, RT1. Now, since it is a solid disk, the moment of inertia of the solid disk about this axis can be written as what? mr square by 2. And then we have to put here alpha. Agree? Keep this equation safe. Now we'll frame the equations using the Newton's second law on this mass as well as on this mass. Suppose for this mass we use the Newton's second law. Acceleration is in this direction, means the net force is in this direction. Using Newton's second law for this mass here, I am writing the expression. We should write mg minus T2 is equal to ma. mg minus T2 is equal to ma. And we are writing the Newton's law for this mass also. then acceleration is up. It means T1 is dominating. So the expression would be T1 minus m by 2g is equal to m by 2a. Agree? Call them equation 1 and 2. This is 1, this is 2. I'm going to add them by 1 plus 2. Let's see what we obtain. We are getting mg minus m by 2g. So it will be m by 2g. Then we are getting here minus t2 plus t1. Means I can write it like this. You get it? When we add them, here is mg, here is mg by 2 negative. So mg minus mg by 2 is mg by 2 positive. Here is t1 positive, t2 negative. We have shown it. And then here we have m plus m by 2 into a. Okay. Simplifying it further, m by 2g plus t1 minus t2 is equal to 3 by 2m. Now this a, since there is no slipping, the a must be equal to alpha r. Why so? I am proving it on the next page due to limitation of the space on the previous page. Suppose this disk has the angular acceleration alpha. Then you check the tangential acceleration of this point of the disk. If this distance is r, then the tangential acceleration must be alpha r. Now there is a rope passing over the pulley. I am showing the rope like this with the yellow color. This is a rope which is passing over the pulley. Question says there is no sliding between the rope and the pulley. It means this point of the rope should have the same acceleration as the tangential acceleration of this point of the disk. It means this a should be equal to alpha r, because the question said there is no slipping between this rope and this pulley. So here at the place of a, we can write alpha r. Do you agree? Now we call it equation number 3. Call it equation number 3 and call it equation number 4. Simplifying these two expressions will be getting our angular acceleration. I'm taking this data on the next page. We have to simplify these two equations. So let's start the process. From here, I can write m by 2g minus 3 by 2 m alpha r is equal to t2 minus t1, because here we require that t2 minus t1. Now this r and this power is getting cancelled out. t2 minus t1 I am submitting from here, m by 2g minus 3 by 2 m alpha r. M by 2g minus 3 by 2 m alpha r is the t2 minus t1. This is equal to mr by 2 alpha. Okay, m by 2g. Now shifting this term to the right hand side is equal to 3 by 2 m alpha r plus 1 by 2 m alpha r. Got it? Here we can take few parameters common. So in left hand side I keep m by 2g as it is. Here I am taking that m alpha r by 2 common. M alpha r by 2, m alpha r by 2. So we are left with 3 plus 1. Here 3 and there 1. This 2 and this 2 is getting cancelled out. This m and m is getting cancelled out. So we are having the alpha with us. Alpha comes out to be g by 4r. That is the first option of this question. It means the correct answer should be this, g by 4r. So the concept is pretty simple for such question. You can solve such question in 4 steps. Number 1, draw the free body diagram. So we have made the free body diagram. Number 2, assume a comma alpha. We have taken the a and alpha in the proper manner. And then use the Newton's second law. We have used the Newton's second law here. And finally use torque about the center of the pulley, since it is hinged. So torque of this hinge force and the torque of mg went away. Its torque is 0. Hinge force has 0 torque about center. The mg has the 0 torque about the center. So we have written the torque of T1 and T2 only. Writing the torque properly and then simplifying the equations, you get your correct option. If you have any doubt, please post it in comment box. I'll surely reply for that. Stay awesome. Bye-bye.